Okay, so despite the data following a straight path, which is your line of regression, the data is scattered around the line of regression. The degree of scatter is described by the correlation coefficient. So lowercase r, the correlation coefficient, is a measure of strength and direction of the linear association between an independent variable and a dependent variable. The line of regression is a value between -1 and +1. So R, the line of regression, will be a value less than 1 and greater than -1. If the line of regression is either -1 or +1, we can say a correlation definitely exists. If the correlation coefficient is approximately 0, we say that no correlation exists between those two variables. The sign of the correlation coefficient is equal to the sign of the slope of the line of regression. So for example, the slope of this line of regression, since it's going up and to the right, is positive. So that means the correlation coefficient we calculate will also be positive. By contrast, in this other example, the line of regression has a negative slope because it's going down and to the right. The correlation coefficient for this line of regression will also be negative. Now, if the correlation coefficient is close to 0, then that means you've got a slope that's also approximately 0. And so a line with a slope of 0 has no rise to it. It just has a run. Okay, it doesn't go up and over, up and over. It has no up. It only goes over. Okay. Another case where you could have a correlation coefficient that's approximately 0 is if there's no pattern at all. So on the previous one, you could see that there was a pattern. The pattern was a horizontal line. Okay. But this horizontal line pattern means that there's no correlation. Another way to get no correlation is if there's no pattern at all. So with no pattern, that means you could draw a line of regression in any direction. There isn't any one way to draw a line of regression. You could draw them anywhere. So because there isn't a clear linear path, then there's no correlation there. The correlation coefficient is 0. Here in these examples up above, there's only one way to draw a line of regression. It's this way, up and to the right. If you're to draw anything else, okay, it wouldn't be following the data points, right? It wouldn't be following the scatter plot. Whereas down here, there isn't one single path, that looks right. It could be a multitude of them. So on the NumWorks calculator, you want to use the regression app, put in your data, and then view the stats tab. On the TI-84, you want to use this linreg ax plus b function. Okay, so that's an extra page I got to remove. All right, so what does the magnitude of the correlation coefficient represent? Okay, we know that if the correlation coefficient is positive, so if we have a positive correlation coefficient, then our line of regression is going to go up and to the right. If we have a negative correlation coefficient, then our line of regression is going to go down and to the right. All right, but what about it being, something other than 0 and other than 1 and -1? What if it's some value in between? So what we've got here is I've got three different positive correlation coefficients of different values. Now, if you pause the video and look at these, look for a pattern between the value and the scatter plot and the line of regression. What do you see? Well, when you have a correlation coefficient of 1, the scatter plot is pretty closely bound to the line of regression. There's very little up and down scatter around the line of regression. The data points are pretty close to that line of regression. As soon as the correlation coefficient starts to go towards 0, there's now a little more scattering around the line of regression. And as it goes even further closer to 0, the scattering around the line of regression increases to the point when you get a correlation coefficient of 0, and now there's just no pattern at all. There's no clear pattern at all, okay? So typically, the strongest correlations are going to be +1 and -1, okay? The only thing the negative means is that it's just going in the opposite direction. A correlation coefficient of -1 means that the scatter plot points are tightly bound to the line of regression, but just going down and to the right instead of up and to the right. All right. And you can kind of see here over to the left that once the correlation coefficient starts to drift towards 0, from -1 to -0.5, then the scattering in the scatter plot starts to be looser and looser bound to the line of regression. So that's what the magnitude of the correlation coefficient represents. It represents how close the scatter plot points are to this linear regression, this linear relationship, this linear correlation. Okay. And finally, on the correlation coefficient, it's one thing to walk up and tell somebody, okay, I did a linear regression analysis and the correlation coefficient was 0.7. It's like, okay, well, someone, I guess, experienced in it would kind of know what 0.7 was, but a lot of people want to just, instead of saying a number, they want to use a word to describe it. And so there's this translation table that lets you convert like a value of R into a literal description of R. So what do I mean by that? So earlier we looked at ice cream sales versus shark attacks. Well, the correlation coefficient of that came out to 0.794. So because it's 0.794, you look and see where that fits in this first column. Well, 0.794 would be right here between 0.60 and 0.799, just barely, right? So this would be considered a strong correlation. 0.794 is between 0.6 and 0.799 in the table above. So the correlation between ice cream sales and shark attacks is strong. So I told you there was a correlation between those two. But again, even though two variables are correlated, that doesn't mean that one causes the other. I meant to put causation, but kind of wrote what I said. Correlation is not causation. They're not the same thing. All right. Let me know if you have any questions.